Hi there, Algebra 1. Section 4.5, writing a function rule. Objective is to graph equations that represent functions. Many real-world functions, functional relationships, can be represented by an equation. You can use an equation to find the solution of a given real-world problem. A landfill has 5,000 tons of waste in it. Each month it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after a month? So initially you're starting out with 50,000. So we automatically already have 50,000 out in our landfill. Okay? It is saying if we keep filling this, find our total, so total is going to be, that might be too far over. Actually, go right. So 5,000 is our total. Or, yeah, 50,000 I should say. Is our total that is there initially. You're going to keep adding to it at 420 more per month. Okay? We want the function rule. Now, how would we ever represent 420 for X number of months? Or we don't know how many months. It could be 4, it could be 5 until we sub in that. We're trying to create something, an equation that'll work no matter what I plug in there. Well, 420 is going to happen every month. So, I'm going to times that by the number of months. So I'm going to throw in M for that so I can sub in whatever number that is. Plus the 50,000 is going to get me my total amount of trash. That's in the landfill. Okay? So that would be the function rule for that one. Okay, writing in evaluating a function rule. A kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost for n days. Okay? Well, it costs $15 per day. So to find out what it costs per day to be there, and maybe it's 5 days, maybe it's 6. I'm going to have to take it times 15 times the number of days. Well, it says for days, put in n. Well, we don't know how many days it is, so does n days. Alright, now that would tell me what it costs to have him there for that many days. But in order to even go in there, he automatically has to have the $12 flea bath. And he's not going to get that every day. So you're going to have to add a $12 to that to get what it would cost. Okay? So that would be your total cost. Okay? This is what it costs for every day. This is just so you can get him into the boarding kennels. Okay? How much does it cost for a 10-day stay? Well, we know this is how many days it is. N is representing that, so we take 15 times 10 plus 12, and we get, that's going to give me what, 150 plus 12 is $162 to have your dog in there for 10 days. Does a 5-day cost half as much? Well, let's figure this out. 15 times 5 plus 12. Okay, you're going to get what? 75? 75 plus 12, which is $87. 87 times 2 is 174. So is it half as much? No. Why? Because the flea bath was the same no matter how many days the dog is there. So, that being said, no, because the flea bath costs the same no matter how many days the dog is there. You know, if you're just going off what it costs to stay there, yes, it would be. But in this case, we got that flea bath, which is just a straight initial cost, is going to not work out. Write a function rule for the area of a triangle whose height is 4 more than twice the length of the base. What is the area of the triangle when the base is 16? Okay, write a function rule for the area of a triangle whose height is 4 times the length. So, how do we find area of a triangle? 1/2 base times height. Alright? Write a function rule for the area of a triangle whose height is 4 more than twice the base. So your height equals base times 2 plus 4. So height really here is 2b plus 4. Okay? Now, this is what h equals. If h equals that, can't I sub this in for h? 1/2 times b times 2b plus 4. Okay? Well, this is really 1/2 b. So 1/2 b would give me b squared, because you'd end up with, multiply our outside numbers together, you get 2 over 2, and then you'd add your exponents, which is 1 and 1, so you get b to the second. Okay, you're going to take it times this, plus, actually, I don't even know if I have to be this accurate, but I'm going to do it anyway. So I'm going to distribute it here. I'm going to get 4 over 2b, which means I'm going to have b to the second plus 2b. Okay, b is base. So to find the area, I would have to go in here 16 squared plus 2 times 16. This is 32. That one would have to be not quite 300, I don't think. I want to say like 280 something. No, 256. Plus, so you end up with 288 inches squared. Okay. Graph the function and determine if it is linear. Oh. Okay. So, if I'm going to graph this, I am now going to put a
ton of extra work into it. And when I say that, it's not saying I'm just looking for a very easy way to do this. I am just looking for a way to represent this and make your life really, really easy. Okay? So, what I would do here is go A equals, because that's going to be my area, equals 2, or no, it'd be B squared plus 2B. Okay? I'm going to make a chart. My A's, which are X's, we're going to say, and my B's, which are, no, my B's I want here. B's are going to go here, A's are going to go here, and they're going to be my Y value. Okay, if I plug in 0 here, I'm going to get 0, right? I plug in 1 for my B value, I'm going to get 1 squared, which is 1, plus 2 times 1, which is 2, so this is going to be 3. Then I'm going to plug in 2. 2 times, or 2 squared is going to give me 4, plus 2 times 2, which is 4, so that should give me 8. So if I had to graph this, I'd have a point here, point here, a point here. You'd have something like that. So is that a linear line? No. Okay, write the function rule for the following. Let me erase this so you can see it. Alright. Write the function rule for the following. The almond extract the remaining in an 8-ounce bottle remaining after taking each batch of cookies that uses 1/4 of an ounce for each batch. Okay, so you want to know what's remaining after each batch. So, you have a bottle that is 8 ounces. So R, which is going to be my remaining, is going to equal 8, because that's what I started with, minus, okay, and one batch would just be 1/16, right? 1/6, my bad. 2 batches would be 2, so you'd have 1/3 to be taken out on an ounce. So you're going to take that times the number of batches. Well, we don't know how many batches there are, but we can create a formula that tells me no matter how many batches, I should know what's left. So that would be my function rule for that one. You go to dinner and decide to leave a 15% tip. You had $55 when you went to the restaurant. Make a table that shows how much you had left after the meal and tip that cost 15, 21, 24, and 30. Write the function rule. Okay, now when this takes place, it's a little bit different. Okay? I'm not even sure where I got this question. Alright. So, I had to graph this one. I'll do it here. Okay. You had $55. So up here we're going to put this as $55. This is going to be, let's say, 45. This is going to be 35. This is going to be 25, 15, 5. So yeah, something like that. Okay? So, if you spent, so this is cash before okay. At zero, if I spend $0, I'm still gonna be at $55 left, right? If I spend 15, dollars, if I spent 15, that's gonna leave me about 40, right? So there I am. Okay. If I spent, this is 25, I spent 21. Okay, that would leave me with 55 minus 21 would be 33-ish. Okay, if I spent 24, that would leave me with what? 31. Okay, if I spent 30, that would leave me 25. And obviously this isn't completely accurate, but you can see that there's a kind of correlation there. Okay? Now, we were basically using the function rule the whole time. Left over, we were always finding by taking KL is what I'm going to use, cash left over. We were always finding that by taking cash, or $55 I guess, because that was the initial amount, minus KS, or CS, cash spent, and getting what was left. So this right here would be your function rule in that one. And we did it like the whole time we were doing it. What advantage can you see having a function rule instead of a table value to represent the function? Example, what is the output for an input of 9? Okay, if I kept going with the table, I have to basically extend this as 5, 6, 7, 8, 9. Now, if I can find out what's taking place in this one, every single time in the chart, and find an equation based on the chart, and honestly, I don't think a chart is a way to find it because I'd always have to go on and on forever. But it is a good way to find your function rule. So, right here, if you subtracted those, you would end up getting, so we gotta see if what this function rule does. you get 95 cents. Do this one. You get 95 cents. Do this one, you're gonna get 95 cents. So every time here, from here to here, I subtracted one backwards to find, because then I know the difference every time. Every time from here to here, we actually added 95 cents. There's a 95 cents difference here. So, what's taking place is you have this initial amount, which not 100% sure what that is right now. I can find it though, because I know what I have to do to find it at 0 would be subtract 95 from that, which is going to be 695. So that's my initial amount. That's what it's going to be at the beginning. So, no matter what, if I didn't get any extras, let's say this is a pizza, I didn't get any toppings, they charge me $6.95 for my pizza. Alright? Then I want to find out what it costs if I throw on 1, 2, 3, 4 toppings. Well, each topping is going to cost me 95 cents. Okay? Well, I don't know how many toppings I want, but I want to know, if I throw on 3, what is it? In this case, I want to throw 9 on. Well, how would I do that? Well, I'd have to take 95 times that. So, times T, we'll say. Because I got you thinking of topping. Alright, so then you'd plug in 9 here and then solve. If I did this, I would have to, and I'm going to write over this, I would have to go 5 and then have to add 95 here. Which is 1176, so then I'd have to add 95 again. Then I have to do it again, add 95 again. And then I end up with this, which is actually going to be the same thing I get here. Now, real question is, I'd have to type it in my calculator once. And I can maybe do that one in my head. This one I can do in my head, but there's a lot of steps. And if I use my calculator, I had to type it in. Let's see, 1, 2, 5 different times. This was quicker. That's why we try to create an equation. Now, and then if this is at the 100, it'll take you forever. Or I can just plug in 100 there. Alright, write the function rule instead, g cost. Which is really funny, because I didn't actually know that was going to be the rest of it. But I actually did this one. This, it goes with this. Okay? Shocker. Amazing how that works. So we had already done the bottom one, based off what I just done. There is your homework. There you go.